Okay, so in this video we will start with some examples of similar right triangles. And this one states, find a similarity statement for the three similar triangles, then complete the proportion. Okay, so it doesn't matter what the actual letters are of the right triangle, right? In the example I did in the beginning, or the notes, I used triangle ABC, right? Okay, so it doesn't matter which order you want to state it in, the ordering the letters, as long as you are consistent and as long as they're lined up. Okay, so I'm just going to say triangle. I'm going to start with the big right triangle, triangle DEF. Okay, so instead of drawing everything out again, because that takes a lot of time, right? The way I stated it was I went from the short leg basically to the long leg. And so you're going to have to make sure you're going from short leg to the long leg when you state the actual triangle for the other two. So triangle DEF is similar, right? Now I'm going to take care of this triangle right here, the smaller one, the upper left. Remember, short to long. So it looks like this one looks like it's the shorter leg, right? This one looks like it's the longer leg. So I'm going to say triangle DEF is similar to DGE, right? And then one last triangle, this triangle right here. Again, if you can't mentally visualize, just draw it out on a separate sheet of paper, then you can see everything's lined up. But again, I went from short leg to long leg. Looks like this is the short leg. Looks like this is the long leg. I'm going to say is similar to triangle EGF. Okay, so again, the ordering of the letters, not so much as important as long as you're consistent. Had you said triangle FED, right? Let's say you went this way from long leg to short leg, then you also have to go from long leg to short leg, right? EGD is similar to FGE, okay? All right, now we're also asked to complete the proportion. Now, the way you look at it is, right, they give you DG and EG is equal to question mark over to EF. Well, the way I see is that DG is the short leg right here, right? EG is the long leg of this triangle right here, right? Short is to long. That means on this side of the proportion, this also has to be short. And this also has to be long. Now I take a look at EF, right? EF is the long leg of this triangle right here, right? Oh, sorry, EF is the long leg of the big right triangle. And in the big right triangle, right, the shorter leg is clearly going to be DE. Okay, so DE would be my answer to this one. Okay, so that's how you want to think about it. Short leg, so long leg of this triangle. DG is the EG. Short leg, DE, the short leg, is the long leg of the big right triangle. All right, moving on, you can use that same concept, excuse me, to find the value of the variable. And so over here, you're going to be solving for whatever the variable is, right? Whatever they name it. In this case, they call it X. And they already give you three side lengths. And this is the classic, similar triangles within the big triangle. There's three similar triangles, right? That was the point of today's lesson. And you can write up your proportion however you want, long as you are correct in your actual proportion. All right, so if I want to find X, right, X is clearly going to be the shorter leg of the triangle right here, right? And over here, I'm going to use my hypotenuse. So I'm going to start with this triangle. I'm going to say hypotenuse is to shorter leg. And that's the ratio I'm going to use. Okay, hypotenuse is to shorter leg. So in this triangle right here, the hypotenuse is 12. The shorter leg is X, right? And then I have to be consistent. Now, I already have all the values in the big right triangle, and the hypotenuse of the big right triangle is 13. The shorter leg of the big triangle right here is going to be 5, right? And so when you cross multiply and solve, you're going to get 60 equals 13x. X is equal to 60 over 13. Okay, so I just want to let you know that there's more than one way of doing this, right? Had you gone shorter leg the hypotenuse, doesn't really matter as long as your proportion is consistent and they correspond. Okay, so just like solving similar polygons, right? I said trust the similarity statement and make sure everything is lined up when you write out your proportion. Okay, so different type of problem right here, right? They're asking you to solve for k, and they don't give you the value of this right here, right? Which is fine, right? If you want to use k, if you want to solve for k, right? K is clearly the hypotenuse of this triangle right here, and 2, right, is the number of the shorter leg, or the value of the shorter leg. So we know that all 3 triangles are similar to each other. So I'm going to, again, use this relationship. Hypotenuse is to shorter leg. And I'm going to start with k is to 2, right, of this small triangle right here, as hypotenuse is to shorter leg of the big triangle. Right, the hypotenuse of the big right triangle is 10. The shorter leg is going to be k. When you cross multiply, you're going to get a square root equation, and make sure you take the square root of both sides. All right, so make sure you write in simplest radical form. This is 2 square root of 5, and that's how you solve for k. Okay, let's do another one. Tell whether the triangle is a right triangle. If so, find the length of the altitude to the hypotenuse round to the nearest tenth. Okay, so this is kind of a review of what you did in the previous section, or last week, right? The converse of the Pythagorean theorem. So 4 root 13, or actually, I'm sorry, I'm going to move on to another problem before then. Let's do part C first. Okay, so again, this is still finding the value of the variable. I kind of skipped ahead here. I've always been doing hypotenuse is to shorter leg, right? But in this problem right here, it looks like they give you the hypotenuse on this triangle here on the left, and they also give you the longer leg. So, it just depends what they give you. Okay, so the ratio I'm going to use is hypotenuse is to long leg. Okay, now the hypotenuse of the the hypotenuse of this triangle right here is 2x minus 4. And the shorter leg in this problem right here, the longer leg is just going to be x minus 4. All right, so again, I need to be consistent, right? Hypotenuse is the long leg. But I'm also going to compare. I don't really want to compare this triangle right here because I don't have enough information. I'm going to compare with the big triangle because I know all 3 triangles are similar to each other. And the hypotenuse of the bigger triangle is going to be x plus 4 plus x. X plus 4, right, plus x. Okay, so the length of this hypotenuse is x plus 4. Okay. And then, of course, the longer leg of the big right triangle is just going to be 2x minus 4. Okay, so hopefully you can see that relationship. That's really the concept, right, of setting proportions within similar triangles. Okay, now the tricky part of this problem is to review your algebra skills, right? I need to cross multiply. So this actually turns out to be 2x plus 4. And whenever you're cross multiplying, you have an expression, right? Make sure you put it in parentheses. So if I multiply this times this, I'm going to get 2x minus 4 quantity squared. And when I cross multiply this, I'm going to get 2x plus 4 times x minus 4. All right, so remember how to square a binomial, okay? So if you square this, recall a minus b squared is a squared minus 2ab plus b squared. Okay, so a little bit of memorization on foiling. So I square the first term, I'm going to get 4x squared. This term times this term, 2x times negative 4 times 2. So that's negative 8x times 2 is negative 16x. Square the last term, you get plus 16. And then for this one, you just have to FOIL, right? 2x times x is 2x squared. 2x times negative 4 is negative 8x. Positive 4x minus 16. Okay, so again, how do I solve a quadratic equation? Make sure you move all the terms over. I like to keep my squared term positive. I'm going to get 2x squared. If I move my minus 4x over, I'm going to add 4x. I'm going to get minus 16x minus 4x. Oh, I see. I made a mistake over here. This should be x plus 4. I was wondering why. This should be an x plus 4, right? Okay, so when I fold here, I'm going to get 2x squared plus 4x, right? And this should be a plus 8x, okay? So a little bit of mistake right here, right? This should be x plus 4. This should be x plus 4, okay? The concept still stays the same. Okay, so this is positive 12x minus 16x minus 12x is minus 28x. This should also be positive 16, right? Because everything's positive now. These 16s are going to cancel out, and I'm just left with a 0 here, okay? So you don't need to use the quadratic formula on this problem right here, right? You could just factor out a 2. And you could use your zero product rule, right? X squared minus 14x is equal to 0. Factor out an x. You're going to get x minus 14, and you're going to get two values. X is equal to 0, x is equal to 14. Now, clearly, it makes no sense to have a psi length of 0, right? X is equal to 14 would be your correct answer. Okay, so just a couple, just to recap this problem right here, right? The concept is, right, set your proportion based on the fact that all three triangles are similar. And, you know, it just depends what they give you, right? They gave me the hypotenuse. They also gave me the longer leg, right? Again, this one's kind of hard to tell, right? You're not sure if this is the longer leg or this is the longer leg, but this one is. And set a proportion, right? If you understand this line right here, that means you understood the concept. The rest from here to here is algebra. I apologize for writing x minus 4. This should be x plus 4 right here, right? That was given to you in the problem. Okay, so now back to example 3, right? It says, tell if the triangle is a right triangle. If so, find the length of the altitude to the hypotenuse. Okay, so as I mentioned, right, based on your prior knowledge, right, 4 root 13, if you approximate this, this will probably be the longest side. You need to see if 4 root 13 squared, question mark, does it equal 8 squared plus 12 squared, right? If c squared is equal to a squared plus b squared, you know it's a right triangle, right? Or if the hypotenuse squared is the sum of the two legs squared, you know it's a right triangle. Okay, so just to review, right, 4 root 13 squared. I know radicals always mess up students, right? Make sure you square the 4. You're going to get 16. Root 13 squared, right, is just 13. Okay, and I explained to you in a previous video why that was. So you can multiply that out, right, whatever 16 times 13 is. 16 times 13 will give you 208. Now you're going to get 64 plus 144, and if you add these two values, it looks like you will get 208. Okay, so this is a right triangle. Yes, it's a right triangle. And if it's a right triangle, right, you know that within that right triangle, there's three similar triangles. So let's go back to this part right here. If so, find the length of the altitude to the hypotenuse. Okay, so the altitude, right, to the hypotenuse is the perpendicular distance from the vertice to this, right? This is the hypotenuse. This is called the altitude. Okay, so that's just a little vocabulary I kind of explained in the beginning of the notes. All right, so now this is just a problem of finding x, right? Or maybe call it h, whatever you want to call it. And you're setting a proportion again, okay? So I'm going to go, it looks like this guy right here on the right side, right? It looks like this is the shorter leg between this and this, right? And this triangle right here. So I'm going to go hypotenuse is the shorter leg. And again, you can use many different ratios to arrive at the correct answer as long as you are correct in lining it up. Okay, so hypotenuse is to the shorter leg, is 12 is to h. And then I'm going to go hypotenuse is to the shorter leg on the big right triangle, which is 4 root 13. The shorter leg of the big right triangle would be 8. Okay, and now you just have a cross multiplication problem. I think this one they want you to round to the nearest 10, so you could use a calculator. So 4 root 13 times h is equal to 12 times 8. Twelve times 8 is 96. And you could divide both sides by 4 root 13. Okay, so if I were to say leave it in simplest radical form, right, you would just multiply top and bottom by square root of 13. You get 96 root 13, right? And then 4 times 13, root 13 times root 13 is just 13. 13 times 4, right, that's just going to give you 52. Okay, so this will be exact, and then approximately 96 square root of 13, entering it on my calculator here, divide by 52, it's about 6.6. It says round to the nearest tenth, so I'm going to say 6.7. Okay, so this is the approximate answer, and then this is the exact answer. Okay, so it's helpful to know both because you never know what the directions say, right? I think on your previous homework, I graded some of the Pythagorean theorem problems, and it says leave it in simplest radical form. So you still have to know all your radical skills. Okay, so the last problem right here asks you to use the geometric mean to find AC, which is this, and BD. You don't have to use the geometric mean theorem because, number one, I never really covered it with you. I mean, I covered what a geometric mean is, but there's another theorem as it pertains to triangles. And really, if I give you a bunch of theorems, you're just going to forget it all. But just recognize that once you have a triangle, right triangle, there's 3 triangles that are similar to each other, right? That's the only concept that you need to know. And so if I want to find what BD is right here, well, I'll just call it X. I'm just going to use I'm going to just use the fact that all 3 triangles are similar. So again, on this one, right, they give you the hypotenuse, and then this is the longer leg. I want to use hyp is to long. Okay? So hypotenuse is the long leg. So I'm going to say 16 is to X. As hypotenuse is to long leg. Or sorry, hypotenuse is the long leg. AC is to 30. Now notice, I don't know what my AC is right here, right? But I can find what AC is just using Pythagorean theorem. Okay, so AC squared is equal to 16 squared plus 30 squared. So why don't you find what AC is? AC is the square root 16 squared plus 30 squared. You're going to get 1156. And the square root of 1156 approximately, well, not approximately, it's going to give you 34. Okay, so AC is 34. I found that just by using Pythagorean theorem. And my proportion, I'm going to go back to my proportion. This is correct, right? Now I'm going to plug in 34 here. So 16 is to X as 34 is to 30, right? And then you can cross multiply and solve for X. 34X is 16 times 30. And without showing you all the work here, 30 times 16 is 480. And divide by 34, you're going to get about 14.1. Okay, so 14.1, which is my X, is my BD. All right, so in summary, right, these problems aren't super difficult if you know how to line up your similar triangles. Okay, all 3 triangles are similar when you draw the hypotenuse, when you draw the altitude down from a vertice to the hypotenuse, and I proved that with you in the beginning in the notes. Just be careful on some of your algebra skills. You might have to use factoring in this problem. You might have to use quadratic formula. So those are all skills you learned in semester 1 that you'll be practicing perhaps, and also you'll probably use definitely again in Math 3 next year.